Well, okay, let's talk about stats. And you people need to talk like statisticians, so lots of stats words we'll start with, and we'll just keep repeating them until you speak like me. And lots of examples. Are you in business or health sciences?
Health science.
Everybody's in business? Health sciences? Business?
No, health science.
So a split. Okay, no matter if you're in business, that's how they project how they're going to do, what they're going to sell, how they're going to market. If you're in health sciences, you know there's all sorts of places that statistics have shown up time and time again. So we're going to start with descriptive statistics. And that's just what it means, descriptive, and here it is here. So when we talk about descriptive statistics, we're only organizing or summarizing or presenting data in an informative way. And you've seen them all. You've seen the pie charts, the bar charts, all of the rest. So I forgot to give these out.
In case you don't have paper for today.
Yeah, and here's some. Can you get these out too?
Yep.
So to start with, we're just going to, this is basically a review because we're assuming you've all done stats before. This course is so packed. We do 15 chapters. So the beginning, just so I get to know you, you get to know us, and get to do the terminology. I'm going to actually do the handout that we were going to give you to do on your own. So in this first part, we're going to do descriptive statistics. And from here, I'm making no inference, nothing. I'm just going to take the data that I have and display it some way to make it easier for my audience to understand. I'm not going to say, because this class had an average of 87, that somehow is it inferred to be something different for someone else. So let's first of all talk about the type of data that we have. There are two types. One is quantitative, and one is qualitative. Can you give me an example? Yeah.
In quantitative, I think it's for numbers.
Yes. The word quantity means how much, yes?
This like 2 to 5.
This would be like a trade. What's your favorite color?
Pink.
Okay. What's your favorite singer? What's your favorite movie? These answers will be words, yes? So we do very little in this area because, of course, we can't calculate anything. So we have two types. Qualitative, and that would be, if you were doing research, it would be case studies or something to do with where I'm speaking to you and you're telling me something and I'm taking notes, right? I can codify it so that if all of you said the same thing, everybody said their favorite color was pink, I would be able to write that as a conclusion. But when it comes to here, I'm going to get some numbers. So how many animals do you have? How many sisters do you have? How tall are you? What do you weigh? All of those kind of things will fit in here. And from our quantitative list, we have two distinct types of data. And we use different formulas and different approaches according to the type of data. So here we have discrete. And here we have continuous. So discrete would be like counting. How many students in the class? 1, 2, 3, 4, 5, 6, 7. That's discrete. Yeah? Stats?
Yes.
For continuous, it would be how tall are you? And the reason that that's continuous is that I could say that I'm 5 foot 6 inches, but am I exactly 6 inches, or am I 5.9 inches or 6.1 inches? And there is no stopping, right? The numbers are continuous. How much fuel did you put in the car? What do you weigh? You know? And another one in here is money. It's continuous. The fact that we round to the closest real or dirham does not mean that it's not continuous. So here, basically how much? And we'll return to these numbers, so or these words again, so that you will be using them. Questions about this kind of division here? And you can see why it would be different. The probability of me choosing a woman in this class is 1, 2, 3, 4, 5, 6, 7, 8 students. It would be 6 in 8. But if I were then to choose what would be the chance of finding a 5'6" woman, then I'm going to have to include those people that are close to 5'6" to see it's very different. Questions on this? Okay, we all, well, let me move down. And there are examples in here as well. And the inferential statistics is when we infer something. So usually what we do is we take a sample, we find out something about the sample, and we infer it on the population. For instance, if Pepsi wanted to know if they were really filling their drink cans correctly, they would take a sample, find out what the amount of liquid was in them, and then infer that all their cans had the same amount. That's inferential statistics. And we do a lot of that. So our first units are on descriptive and everything else is inferential. Same as I could choose this class to be a sample. So let's talk about sample and population. Okay, we have a population, and we use different symbols to identify the population, so that if you're reading an article or I give you something and it has one symbol, you know I had a population. If it has a different symbol, you know I started with a sample. So I could say that I only care about you. So my population would be MA1670/1. And that would be a population, and I would write everything about you. Do you see? I could use you as a sample and say you represent the college. But do you see where that would be a bad sample? That you are not representative of the college. First of all, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are more than, it's not a 20-80 split for men and women. Do you see? So if I used you as a sample of the college, there's only 2 men and 8 women. This would be a bad sample. How many categories in here? 1, 2, 3, 4. So again, that's 40%, but the college has 70% categories, so that would be another bad representative. We've got health sciences and business only, so no representative of engineering and no representative of IT. Do you see? So when you choose your sample, we want it to be representative of the population. So not that you wouldn't be a great population, but you'd be a bad sample. So here, if I wanted to find the mean, if I'm using a population, I would use this symbol. And if I'm using a sample, I would use this one. And for standard deviation, I would use this one. And for a sample, here. And if I were to find the number I had, if it's a population, it's a capital N. And if it's a sample, it's a small n. So when you start reading articles or doing your own research, you're going to end up using these symbols so everyone else will know as well that you've either started with a population or you started with a sample. Questions? Everybody's happy with this? Okay, and we have some other words as well, but we'll just start with today and use them forever. In the handout, the graphical techniques, let's just start so we can go through what's here. We're reviewing the charts that hopefully you already know. The first one is a histogram. Let's see if I can collect some data. So I'm going to collect some data on the number of, let's see, how about animals? So I'm going to say the number of animals, and I'm going to define them as having 4 feet, okay? Just because you might have a snake as a pet, you might have a parrot, but to be distinct in statistics, we need to say what we're really looking for. And so I'm going to look for how many 4-legged animals that you have. So first of all, I'm going to make up a table, and I'm going to do some counting. How many? How many pets? None? No cats, dogs? Nothing? Horses? Whoops, sorry.
Have 2 cats.
2 pets. 1 cat and 1 turtle.
1 cat and
Turtle. Turtle.
Turtle.
Yeah, turtle counts. That's 4 legs. That's what you said, right?
I didn't say, yeah, I didn't say warm-blooded,
No.
okay? I too have a turtle. Nothing?
1.
How many
1
pets?
pet. 1 pets. No?
You have none? Pets? None?
No.
Adam?
None for me.
I have 5. Okay, so we've collected the data. Is this going to be quantitative or qualitative data?
Quantitative.
Quantitative, right? Qualitative would have been me asking you what kind of pet you had, and I'm writing the answer in as turtle. Okay? In here, is it discrete or is it continuous?
Discrete.
It's discrete. You got 1 or 2 or 3 cats or animals, you do not have 1.5. Regardless of size, kitten or whatever, it's a full animal. So these are discrete, as they are. Okay, and we would also call this group exhaustive. It means that there was a slot for all of you. So if I had only gone to 4, this would not have been exhaustive because my 5 pets would not have been on the chart. Do you see? I must make a space for everybody. So if there was somebody here that had 8 animals, I would needed to have put 8 in here. And the other one is mutually exclusive. And what that means is that once you tell me how many pets you got, you're only fitting into one place here. If you've got no pets, I can't put you into 0 and to 3 at the same time. There are other mutually exclusive things. If I asked you your religion, you could fit into only one space. You cannot be Christian and Hindu at the same time. If I asked you what your major was, you would be in business or in health sciences. In this college, you can only have one, mutually exclusive. And this word will show up a lot of times when we're doing probability. Questions about those 2 new words that we've added in?
The mutually exclusive one, I'm a bit confused. That you should belong to one thing?
Yes. So if I counted the number of women in here, you can only be in that crowd. You can't be in the men and women crowd. If you, well, I was going to say, in the States you could be Republican or Democrat, but that may not be exactly so.
Ma'am, can you repeat that exhaustive one?
Okay, how many people in the class? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So I would have started with this, that our population was equal to 13. I better have 13 marks here, right? 5, 6, 7, 8, 9, 10, 11, 12, 13. If I didn't, if I'd left this one off, then we would say it's not exhaustive because I've left somebody out of here. So we must have a slot for everybody. So if I stopped at 4, I'd have been missing. Okay, so you have to be careful when you do your graphs that there's one in here, a pie chart of different types of music from store, but there is no indie music on there. So by not putting that on would mean it's not exhaustive. Okay, so this is one way that I could show the discussion about the animals or the pets that you have. So I would be writing 813001. That's one way. I could also do it in a histogram. And need to label. Without labels, in fact, you should be able to look at the graph and tell me everything that the frequency distribution table has shown you. Up the side, I'm going to do frequency. So I love this textbook even though it's wordy, because when you do stats, the fact that I've collected data from you, you may be a very unique class. You know, in other words, I'm not saying that the number of pets in MA1670/2 is the same. I'm just going to say it's for this class alone. And you'll notice in the textbook, it talks about oil changes in, say, New York City may be very different than the oil changes in Southern California or in Doha. Okay, so my histogram is going to have 8 for 0, 1, nothing, nothing, no, 3 here. Nothing, nothing, and 1. We would call this a front-end loaded graph. In other words, more of you have no pets than us with pets, so that would be front-end loaded. If I was going to put your marks together on a histogram, so the marks look like, I'll just sketch one. So this would be 0 to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. This is marks now. We'll call it term test 1. How would you want this graph to look? Would you want this graph to look like this one? I hope not. This graph will not be front-end loaded, will it? It will be what we will be saying skewed to the left. This is what we're going to want to see. Yes? Do you get it? If it was skewed to the right, which is this one, it means that you're failing. So we would want it to look like this. Last year, everybody passed. They came to class and did the assignments, did the Kia. So I'm hoping the same picture here. Questions about the histogram? Okay. We also could have done a frequency polygon. Do you know what a polygon is? This polygon? Polygon is a closed figure, yes? Like a pentagon. That is a pentagon. Or a quadrilateral, something that's closed in. So frequency, and we would have had so here we would have had 0 and A. So even though you can't have a negative animal, we would still have started back here on the axes. And so 0 and 8, 1 and 1, 2 and 3, 0, 0, 1. And then at 6 we would have another 0. So you need to start at 0 and finish. So it would look like this. So I could use the exact same data as I have. I've shown you once in histogram. I'm now showing you the same data in a frequency polygon. That's your choice. Whatever you think the audience is going to enjoy better, this is the kind of graph you would have for market sales, right? Or a temperature chart or something like this you could use. Whereas histograms, sometimes easier to see in groups.
And I didn't get the point why we're taking the negative side of the x.
Well, this is not a polygon, right? Because it's not closed on here. So we have to start and finish on the axes. That's why there was nobody in 6, but I put 6 in, so it's here right at the axis. So if I were to redraw this, do I have another color? So the actual polygon is this. Closed in, see? So we have to start at the beginning and end.
And then let's say the number of the frequency for the number of spike is 0, so we don't go for the 6th.
Yes,
right?
you wouldn't have to do 6. Well, I probably wouldn't have put 5 on, right? I wouldn't have put the last one on. Okay, so page 3 here, we're looking at a bar chart. This is if we wanted to represent, well, I could have, let's just do it this another way here. The same story. But I could have done this. Is there anything else? What kind of data is this? Qualitative, right? No numbers here. I'm asking how many turtles you've got, even though the answer is a number, the graph is representing words or traits. 1 turtle, I'm guessing. Okay, so, and I can do it like this, make it just a bar. I can make it a dot. I can do whatever. I can do like that, okay? And cats? How many? 2? Somebody else had cats. You have 1? 3? You have 1? 4? 1, 5, 1, 6, 7, 8, 9. In fact, I have 3, sorry. Okay, and dogs? Nobody? I have 2. So that's a bar chart. I could have done it with pictures, pictogram, right? I could have drawn little dogs and put them up the side. Everybody's okay with this. Everybody can go into Excel and make a bar chart. Excel does not do a nice job on histograms, however. It cannot make the space disappear. But we're going to use Megastats, which you will get, we'll supply for you anyhow. Okay, what about the pie chart? Any problem with it? How many people went into Joha Music Store? Do you know? No, because pie charts are usually done in percentages. So I don't have a clue whether there was 5 people or 500 people going in there. If there were 500, how many of them liked rap? If there were 500 in the store, how many of them liked rap? 250. Half the people going in. I'm not really sure about that. How many in the class would have gone into the store and bought rap? Would that be nobody or you? No one? I thought that. Okay. Okay, we also have an OGIV, which is cumulative data. And in that one, we're asking questions, how many people got below? So can you find the data? So let's take some data from the textbook. One of the things that I want you to understand is that we get a choice to do what we want with the data. So in one case, I may ask you to draw a histogram. The next time I might ask you to draw a frequency polygon. But if you're doing a report, you're doing whatever. You choose whatever you think is going to be the best way to show the people what's going on.
Again.
Did it not like it?
No, it did. You have to unlock both computers. What data do you want?
It's chapter 2, it's, I think, it's the second group of questions.
You want to do the problems?
Yeah. Not the first part, the second part.
Oh, page
Now
30.
keep going.
Yeah, page 30.
That one will do. Move back. Okay. Can you see the numbers? The commissions earned for the first quarter of the last year by 11 members of the sales staff at Masterly Chemical Company. Is it a sample or is it a population? Do you think that it's not really clear here, but do you think that there are only 11 members of the staff? If you think that, then it's a population. If you don't think that, then it's a sample. And what are the values such as 1650, 1475 called? That's data. And is it continuous or is it discrete?
Discrete.
No, it's continuous. Money's been rounded.
Oh, yeah.
Money is always continuous. It's been rounded. And it says using 1400 up to 1500 as the first class. So now we're adding something else onto here. We're going to group the data. Because for me to write, for the animals it was okay. That was discrete. 0, 1, 2, 3. For me to write all the numbers that started at the smallest amount, 1475, up to the 15 or 1600 would take me forever. So I'm going to put them into groups. And so we call that a class. And for the first one, that it's telling me that I want to do 1400 up to 1500. And this means up to, not including. So I'm only going to go up to 1499. And once I've made this class, I'm going to make my classes all the same. In histograms, you don't need to do that, but when we're using them here, we are going to make them all the same. And am I far enough? Do I have I, and I would be asking you, is this exhaustive? Will all my data fall into one of these three categories? Do you understand the meaning of it now? If I had stopped at 1700, this piece of data here, the 1760, would not have been counted. When I'm done, what will I have a total down here of?
1,760.
No, because I'm going to do numbers. I'm going to count. How many should I have?
4.
I need 11. Yes? It told me there were 11 pieces of data. If I have done it correctly and I'm exhaustive, it means that I will have 11 when I total this row. Okay, how many of these salespeople sold between $1,400 and $1,500? 1, 2, just 2. Agree? And between 15 and 16, we have 1, 2, 3, 4, 5. And 16 and 17, 1, 2, 3. And between 17 and 18, we have just 1. So, we never mentioned the graphing calculator yet, but this calculator will be your very best friend. We will be starting next class using it. Please bring the TI-84 Plus or TI-84 of some kind. If you have something else, I cannot guarantee I can help you. And all of the handouts, all of the YouTube videos we have, all of the stuff that I will be doing on the calculator, on the computer and the calculator, all based on this calculator. So if you want to try something else, it's going to be a bit of a trial for both of us. We do everything on here. All of the stats that we do is already done for you on here. What we do is discuss the answers that you get. So for next class, you need this, whether we have iPads or not. Okay, so we have continuous data. We now have it grouped. So if I were to graph this in a histogram, I would start with this symbol. That's to let you know that I'm not starting at 0. So you aren't in any way thinking that there are people making 0 here. And then this is going to start 14, 15, 16, 17, 18. And this is it commission or sales?
Commission.
Would it say at the beginning? Commission. And it's earned in 1 quarter. And frequency. And what kind of company is this? Master Chemical Company. So as soon as I get this histogram drawn, you're going to know as much as you would have done if you were reading this whole graph just by a chart. Much easier to see. Especially if I was trying to encourage somebody to join my sales staff. Well, let's see if this would help. So something like this. So no way that the sales manager is going to be able to say something like, oh, you'll make over 1,600. Because we can already see that, you know, between 15 and 1,600 is what we would call modal class, but we'll do that in the next class. This is the largest. This is where most of the people fell. Questions about this? It's just a repeat of the histogram. I could also be more interested in saying how many people made less than. So in that case, I would use a cumulative graph. So this is just straight frequency. Here I'm going to use cumulative frequency. And the question would be, how many people made less than 1,400? How many made less than 1,400?
0.
So I would start with this, and I write it like this so it makes sense to me. How many people made less than 1,400? I'm saying 0. And in a cumulative frequency graph, I will always start at 0. I just have to find out where to be, where to start it. So how many people made less than 1,500? And all the people that made less than 1,600? How many?
7.
7. I'm asking how many made less than 1,600? It's all of them. And the number that made less than 1,700?
9.
And the number that made less than 1,800 is 11, and I better have this matched up if I've written it correctly. It would be the kind of question that I would say, how many people in the class got less than 50%? That's how we would use cumulative frequency. And the graphs always look like a cliff. And this time I need to get up to 11 here. Okay, so I would start here at 0, right? There was nobody that got less than 1,400. And then up to 2. And 7, 10, and 11. So graph is all of them are going to look like that. If there was a section here of 0, then it would have just been like a platform, right? And I would have gone like this. It will never dip down. There will never be a time I'm not going to bump somebody off and have less people when I'm done. Sometimes when we're doing these, we also want to look at what we call relative. So that means we're wanting to find out how many relative to the full class of 11. So this would be 100%. And therefore 5.5 would be at 50. So I could say that 50% of these people made 1550 approximately. Questions? What else did it ask here? Frequency distribution, describe the distribution, what's the smallest, largest, we did all of that. Just scroll down. To these graphs there. Okay, so let's look at some of the graphs that are here. So we have Molly's Candle Shop has several retail stores in the coastal areas of North and South Carolina. Notice your book tells you where you are. Candles sold on the coast, maybe more than candles sold somewhere else. Many of Molly's customers ask her to ship their purchases. The following chart shows the number of packages shipped per day for the last 100 days. What is the chart called?
What?
What is this chart called? Histogram? What is the total number of frequencies?
50.
Are you sure? The total number.
Okay.
Well, there were 3 here, and 10 here, that makes 13. 18, 31. How many altogether? How many packages did she ship?
16.
Okay, so it says here the following chart shows the number of packages shipped per day for the last 100 days. What will I get when I add these together? I should get 100, yes? What is the class interval? That means how wide are these bars? 5, right? Because one of the things that we are going to do is figure out that you will know how wide these intervals are. So these are 5. What is the class frequency for the 10 up to 15 class? 28. Yes. And when we ask about relative frequency, we want to know relative to them all. So if 28 out of 100 went that day, what's that percentage? 28 out of 100 as a percent? Don't scare me. %? So sometimes we would give, when we give it as a relative one, then nobody knows how many people we interviewed or how many days we did it. All we know is 28% of her days she shipped between 10 and 15 packages. What is the midpoint? That means what's in the middle of this class 10 to 15? It's the middle of between 10 and 15. And do you know why we use midpoints? Because given this data, we don't know in here whether she shipped 25 or 26 or 27, 28 or 29. We don't know that. So we need to have a representative for this group. 25 is like Mama Bear, it's too cold. 30 is like Papa Bear, it's too hot. And the midpoint is like Baby Bear, right in the center, just right. So whenever we use group data, we're always going to find the midpoint. And on how many days were there 25 or more packages shipped? Come on, is it you just don't want to speak to me? It's too early? Question's too hard? Okay, how many packages did she ship? 25 or 30 packages? 10. And then 3 here. So the number of days that more than 25 packages were shipped, 13. Yeah? Okay, so now we have data that's showing us frequency polygon. And this chart shows the number of patients admitted daily to Memorial Hospital through the emergency room. There were never no patients. And notice it begins and ends at 0. So on this one we have a little more work to do because we have to figure out what these values are. What is the midpoint of the 2 up to 4 class? It's the midpoint between 2 and 4. 3. And how many days were 2 up to 4 patients admitted? So it's this one we're looking at. So we would read in here 26, 27, estimating. Approximately how many days were studied? And on this one we would have to add. So 0 looks like 15, 26, you totaling?
No.
Could you? 15, 26, 19,
60,
another 15, 10, and 2.
87.
Okay, so we have